Solving LeetCode 2147, number of ways to divide a long corridor. It is marked as a hard problem. Let's just try to understand what the problem is saying, then we can move to the solution. Okay, so problem is saying that we are provided a corridor in form of a string. We have some seeds and some plants. Now we have a boundary on the left of left, and we have a boundary on the right of right as well. Now we are asked now we are asked that how many ways we can divide this corridor. In divide, what they mean is that we can only divide when we have seeds at least two. Like here we can have at least two seeds, so we can have a divide here. Also we can divide here as well because we have two seeds here. Also seed should also be 2 on the next part of the division. Also this division division of corridor can also be happen in the third index as well, and we have to find out how many ways we can do this. Okay, let's see some examples. Okay, we have one more example. Here we have two seeds and three plants. So if you can see, we only have two seeds, so we cannot divide it further. Okay, if we have one seed also, we cannot divide it further, and also if we have zero seeds, then there is no point in division, we cannot divide. Okay, so first of all, as you see this problem, we get an idea that we need to divide. So somehow we should divide at some point where we are okay on the left side, then we will check on the right side, then again we have a plant, we can still seeds are two. Like this we can have an approach. But if you do some mathematics, if you are able to understand in a mathematics way and do some dry runs of multiple times, then you can actually come up with a very easy approach which does not involve dynamic programming, that we will be discussing. And actually I was able to directly come to this approach since I have already solved this problem previously, not today, that's why. And that time also I didn't study dynamic programming, so I had only this option to solve the problem like this. Okay, let's go to Google Docs and let's check. Okay, so as you can see, we can take this example. Okay, it is pasting correctly. Double S double P S P S. Okay, double S. What is that? Double S double P S P S. Okay, double S double P S P S. Now I'll increase the size for you guys. Okay, so here you can see we have two seeds, two plants, then again a seed, one plant, and again a seeds. Okay, so if I ask you to divide, you will first can make a division here. Okay, this can be one way. Okay, also we have to make sure that if we are making a division here, the other part of division should also be valid. Okay, now if I ask you what other way you can go this way, again this way. So here you can see we can have a division here, we can have a division here, we can have a division here also. Double S double P S P S, right? Double S double P S P S. Okay, this was already given. So this one, and this one. Okay, now we have three divisions: 1, 2, and 3. Okay. Now if I ask you, can you make one more division? You will say you can't make because this S will be included. This S will be included. So this part gets wrong and even the next part gets wrong. Okay, so we can have three division. So here you can have a keen observation that for one part we do not care about the plants in between. We just care about what is the next seed. Next to next, I mean that we have pair of seeds. If you are asked, if we say that next to next, we are making sure that we are considering seeds in pair. Okay. Now I'll explain what I meant by this. Okay, we'll extend this example itself. Okay, let's say we have another two plants and another two seeds. Now if I ask you how can you divide this, you can again start by simply like this, that you will first make a division here, and for the next part how we will do, you will take up till this, at least you have to take till this. Now if I ask you what more you can do, what more you can take this, you can take this as well. So this part can also be the second part, and this part can remain independent. Now if I ask you what else you can make, you can say that SS, and then a P, then P can be spared, then S, then B, then S, then PP, and SS. You can say this. Again, if I ask you what else you can make, so again if I ask you, so you will say like I can take up till this, maximum till this, and for this part let's just keep till this. Now if I ask you, okay, for the first for the first set of seeds, how many ways did you find out? You said that I found out only three ways, because if I take the next part then one more seed will be included, right? So that we should not take, so we can say okay, three ways we found up till here. Now if I ask you, what else you could have done, what else you could have done for the second part. Now for the second part, what could you do? You have to take at least this, then either you can take at least this part, or you could have taken the whole of this. Only two ways you can go with the middle part. Now if I ask you, can you take the this s, you will say you can't take this s, because if we are taking this s, we are making sure that the this middle part is also getting violated, and even the last part is also getting violated. Okay. Now now if you see, I'll put the indexes as well: 0 1 2 3 4 5 6 7 8 and 9. Okay. Okay. Now if you see, let's remove this. You got an idea that okay, if we have some difference between two indexes, then we can have some approach and we can make something out of it. What I mean by this is that, let's say he at these two seats we should come together, these two seats should come together, and these two seats should come together. So we are concerned, or we only have concern over the pair of seats. We do not care what comes in between the two pair of seats. Remember guys, I said pair of seats, between the two pair of seats, not individual seats. Okay. Now let's say we are at index 1. Okay, I'll remove this part. We are at index 1. Because why I'm considering index 1, I'm considering index 1 because the first pair ends at this index. Okay. Now if I ask you where can the next pair start, you will say our next pair can start at 0 1 2 3 4. This is the fourth index it can start. Okay. Spacing should be like this. Okay. So this is the fourth index. Okay. Now if I ask you how many ways could I have, made the split, you would have said this or this or this. So how many ways it was? It was three ways. And you see, 4 minus 1, we have three ways. So if we can accumulate each index of the upcoming seed, then we can have our pairs. So ending index of first pair and starting index of the next pair, we can make our answer, right? 4 minus 1 3. Also we are asked number of ways. If you have learned permutation and combination, then you would be understanding, okay, we have to do a multiplication. We are asking number of ways, right? Okay, now let's move to the next part. Let's move to the next part. So till this point we must have some indexes. Okay, what is the next index that is getting started? The next index that is getting started is this one. Okay, so with what is this index? 0 1 2 3 4 5 6 7 8 9. Okay, this was 6 and this is 9. So here also we can say like this: 9 minus 6. 9 minus 6 is 9 minus 6 is 9 minus 6 is 3. So what was previously we had? Previously we calculated 3. So 3 times 3 is 9. So we will have our answer 9. Okay, now what we can do, let's apply this approach. Let's apply this approach in our case. What we have here: double S double P SPS, double S double P SPS. I think now it will be much clear. When we are concerning only for two pairs, then it will be much clear. See, what is the index till here? Maximum index till here, it is 1 1 for this part. Now what is the index that will be starting from here? It is 2 3 and 4. So 4 minus 1 is 3. Total number of ways 3. And can we make more pairs after this? No, we cannot make more pairs after this. So this is the basic approach. Now what we can do, let's dive into the code and we can understand from the code's perspective. Okay, so also let's first check some edge cases as well. Okay, so let's first count the total number of seats what all they have provided. We'll get to know why I'm counting this. Okay, if seats are 0, then can we make a division? No, we can't make a division. We should have at least two seats, right? Okay, now if seats are 1, can we do something? No, we can't do something. It is also provided here, you can directly see. Also now this one is important. Let's say if seats are in odd numbers, can we ever make a division, correct division? Or can we ever make number of ways, correct number of ways to divide the corridor? We can never make, because let's say we have 7 seats. 7 seats means 7 modulus 2. Then we will always have 2 2 2 and a 1, triple 2 and 1. So one seat will always not make a pair. So we have to return 0 for these cases. Now let's say one very basic case is that, let's say we have only two seats, which is also provided here. If we have only two seats, then you can plant any number of plants in between, left or right. But we are not concerned about plants, we are only concerned about number of at the positioning of the seats. So we will always have one way, so we are directly returning 1. Okay, now what we can do for our main logic, I have made a vector of index that will be saving indexes of the seeds. So in our case it will be saving 0 1, then 4, then 6, correct? Okay, simply what I have done, I have traversed in the corridor and find out where are the seeds, and at the position of the seeds we are pushing those position into the index of seeds. Okay, now I have created the answer starting point will be 1, because we are assuming that at least one way we will always be getting, because already edge cases we have handled here. Now what I am doing, I am at the end point of the first pair and checking the starting point of the next pair. I'm again repeating, I am at the end point of the first pair and checking the starting point of the next pair. Okay, so how I am doing is 0 1 4 6. Okay, I'll type here as well, 0 1 4 6. These will be saved. Now what I'm doing, I'm finding the number of ways. So where am I? I am at index of I plus 1. I plus 1, I'm starting at 1, so I plus 1 is 2, so I'm at 4. Now minus index of I. Index of I means 1. 4 minus 1 is 3, so 1 into 3, answer is 3. Now remember guys, what we are saying, we have to move in pairs. If we have to move in pairs, we need to do I equal to I plus 2, not I equal to I plus 1. And also we have provided that there can be many ways, so we should have a modulus. So normal modulus also we have done, and at the last we are returning answers. Let's try to submit this. Okay, it has been submitted, and if you check the tags, it says dynamic programming. It says you can also do by combinatorics. I have seen that tutorial. And also here you can have a minor optimization of finding the next starting point. Though I'm saving index of seed just for the sake of clarity, you can have an optimization here. Since we do not care about all the previous data, we only care about the upcoming one. You can have like this as well. And let's check the time complexity and space complexity as well. First, I am traversing to count the number of seeds. So here I am taking order of n, and n being the size of the corridor. Now again I am taking a vector of index of seeds, which is again order of n, and again I am traversing in index of seeds. So you can see order of n, we are taking time and space complexity. Thank you guys, see you in the next video.